This show is sponsored by Clothe.com, a developer-friendly serverless platform to deploy apps globally. Stick around until the ad break to hear more. This is Cup of Go for October 6th, 2023. Keep up to date with the important happenings in the Go community in 15 minutes per week. I'm Adelina Simeon.
And I'm Jonathan Hall. Hi, Adelina.
Hi.
It's good to see you.
Yeah.
To hear you.
Yeah, it's really nice to be back. This is my third episode.
Yeah.
And I was just sharing with Jonathan earlier that I'd gone to an interview recently, and the interviewer had heard me on the Cup of Go podcast. So you're definitely making big waves and gathering a lot of support. And, it was a really positive experience to have something to bond with your interviewer about. So if Jonathan ever invites anyone to come on this podcast, say yes.
That's super awesome. We're sad to report that Shai is not here today. He caught COVID, so he is recovering. Hopefully he'll be back next week. We'll keep you posted on that. But we have a lot of news to cover this week, so let's jump in. I think the first thing, hopefully you already know this because you're a responsible gopher and you keep up with these things. But of course, that's why you listen to the show, is to keep up with these things, right? Go 1.20, 1.2, and 1.20.9 have been released with a single CVE fix. This is an interesting one. It allows for potentially execution of arbitrary code while compiling. And this bug has apparently existed since about Go version 1.1. So be sure to update, especially if you are pulling in third-party libraries that you might depend on. This could be an important thing for you to fix. So go update, do your Friday afternoon deployment to the new version of Go, and that's that.
That's so scary. Can you believe it?
Yeah.
It says here that it's arbitrary execution during build.
Yeah. Anyway, let's talk about little happier things. You brought to my attention, Adelina, Hacktoberfest, which was completely off my radar. Would you tell me about it?
Yeah, so Hacktoberfest is running from the 26th of September until the 31st of October. And its aim is just to get people to contribute more into open source. We will post a link to some really cool repositories written in Go that are registered for Hacktoberfest. And it's an opt-in situation. So these maintainers will be expecting people that are new and will be creating a buzz around their projects, and will have extra support for everyone who wants to register and contribute to Hacktoberfest. You get swag and GitHub badges. So, and it's a really, really nice way to get introduced to open source contributions. Some of the Go projects that are registered for Hacktoberfest are Prometheus. You can contribute to Caddy, Bubble Tea, Fiber, and of course, like the Cockroach DB itself, the whole Cockroach what's called organization is open. Yeah, if you have a look on the repo list, these are just some of the ones I mentioned, and definitely get started with open source contributions.
Awesome. I'm a big advocate of open source contribution too, so I'm a little bit embarrassed I didn't know about this already. Let's talk about some proposals. We have several to update you on, and some related news. First, there's a couple of proposals we've talked about in the past that have been now officially accepted. So we want to talk about those quickly. We're not going to go into details. There'll be links in the show notes to the previous episodes if you want the details. The first one of those is that the proposal to shuffle the seed when you're running tests with the shuffle on flag has been accepted. So I think we talked about that just last week or 2 weeks ago. So that one's accepted. A little bit more substantial. We have another one that's been accepted, Adelina. Do you want to talk about that?
So the Russ Cox's proposal to revise the API for Math RAND has been accepted as well. I had a brief look at it, and it seems like it's going to make the API much easier to use, and it's going to add extra support for floats, so making it like loads easier to generate floats. Definitely check it out.
Straying off topic just slightly, we want to mention a proposal that's not on the official Go project, but I like this proposal. Of course, I do because I made the proposal. It's on the GoFumped repository, github.com/mvdan/GoFumped, GoFUMPT. We've talked about GoFumped a couple times on the show. Shai and I have. It's basically a stricter version of GoFumped, GoFMT, that adds additional formatting rules. And I have proposed a rule that would rewrite or clothe naked returns to no longer be naked. And I've gotten the go ahead to add the implementation. So I'm looking forward to doing this. I don't know what's going to be involved, but just because I write the implementation doesn't mean it will necessarily be accepted, because we need to see what kind of impact will this have. So I'm asking the audience to go in and vote up or down. Be honest on your opinion on this proposal. Do you like the idea of clothing your naked returns or not? Be honest. Let us know. Because if enough people don't like the idea, then of course we'll just kill it in the water before it goes anywhere. But I'll link in the show notes to that, or head over to github.com/mvdan/gofumpt and look at the issues. Issue number 285.
I know you're a big fan of naked returns, Jonathan.
I like naked things in other contexts, but not in my returns.
I'm going to be honest. I've never used naked returns, and I was actually in preparation for this episode, I was thinking about what other language uses this paradigm, and I think it's a more like a Ruby way of writing code. I might be wrong. So it would be interesting to see if any Rubyists want to chime in and say hey, don't do this because I'm using it and it's really useful.
Good point. I know that Perl is the other language I used to have extensive experience with, and they don't do naked returns per se, but it has a default return value in any given context. So it's you can't just define 6 values to return and then they're magically returned, but there is a default. So if you just do a return, there's usually some sort of default that sometimes makes sense and sometimes doesn't. One thing I discovered while researching this project, I did an audit of the Go standard library and the top 100 most popular Go projects on grank.io to see how common naked returns are. And I was surprised the standard library, 2.76% of its returns are naked. The average in the top 100 was 1.08%. So the standard library is more than double number of naked returns compared to average. With one exception, there was one repository in that list that had 27% naked returns, but I think it's mostly generated code, so I don't really want to count that. It's kind of an outlier. Enough about that. Let's move on.
We can continue talking about naked returns.
Moving on.
Yeah, so there in 121, the goodies just keep coming in Go 121, there's a blog post that is written about the new support for WASI syscalls in Go 121. I'm not super familiar with the project and WebAssembly in general, but I think it's really cool. I think the blog post is written really well, so it gives you an introduction to WebAssembly and then demonstrates how to use the new WASI support. So definitely check it out as well. I think it's going to be, and it's really cool to have all of the support in the standard library as well.
Mm-hmm. Definitely. The big one, I think, we actually had somebody on the Cup of Go channel on Slack bring this up yesterday. It's perfect timing because of the interview we have that's recorded. I'll talk about that in a moment. But we have a new discussion. I have been eagerly awaiting this one for years, literally, because I've been following some of the issues that this will make obsolete. It is the discussion about encoding JSON v2. A new JSON marshalling and unmarshalling interface has been proposed, or not officially proposed, but it's a discussion now. So this is pre-proposal, but Joe Tsai wrote this just 14 hours ago as we're recording, published it. He did a talk at GopherCon in California a week or two ago on the same topic. So this is kind of the buzz in the Go ecosystem right now, I think. This is probably a bigger deal than MathRand v2. I think Joe told me in the interview that JSON encoding is the 5th most imported package in the standard library. So this is a big deal. I'm curious, Adelina, what your thoughts are on this. Have you been following this at all? Is this brand new information to you? What are your thoughts?
I haven't been following it because I've been kind of on holiday for a while. But I think it's really exciting, and I'm not surprised when you said it's the 5th most imported, because literally everywhere you go and you use the encoding JSON and you don't even think about it twice. It wouldn't even occur to me how else can I do this? Of course you use the encoding JSON, right? That being said, I do think it's a little bit clunky to use. So it's nice that there's going to be an easier way to encode and decode. Yeah, so definitely I'm looking forward for this.
My biggest gripe about the V1 encoding JSON, the one we're all familiar with, is that it lies about streaming support. It takes an IO reader or a producer or writes an IO writer, but it does internal buffering of that thing. So, and I have an API I maintain where streaming is actually important because there, it could be megabytes or even gigabytes of JSON data. So I had to fall back to the JSON tokenizer to do this parsing myself to give true streaming support. So I'm really looking forward to this. In fact, I'm thinking about adding the experimental support to this package I just described, just to see how it works.
They said that they're improving performance as well, right? Because I remember a couple of years ago, we were profiling an application. And guess what the number one resource user was? It was, of course, the encoding and decoding.
Yeah. Yeah, there's a separate a link we'll put in the show notes that shows benchmarks comparing JSON v1, v2, and a few other third-party implementations of JSON encoding and decoding. And when I first started reading it, I was like, okay. Because the first chart it shows where it does Marshall performance on concrete types. So this is like defined structs rather than maps of any. JSON v1, v2 are almost neck and neck. Like a couple tests, JSON v2 is a little bit faster, others is a little bit slower, but they're pretty much neck and neck. But then I scrolled down, and for the rest of them, JSON v2 is like 3 to 6 times faster from any of these tests than JSON v1.
Wow.
So I can't give a blanket statement that it's faster because there are some cases where it's slower, but in general, it is faster and by a big margin.
Is it for like bigger objects, or can you share a little bit?
Yeah, so stick around for the interview to hear what Joe has to say about that. But I'll just give one example. One of the problems with the current implementation, if you ever write your own JSON marshal or unmarshal function on your custom type, you're past a byte slice that you have to then unmarshal yourself. That byte slice has already been unmarshaled once by whatever called you. So there's this reduplication of effort every time you do that. And the new implementation lets you skip that. It gives you 3 different ways to interact with it. You can interact with it with byte slices, as you do now, with readers and writers, or with streams of JSON tokens. So just the design allows for much more efficiency. But I don't want to spoil the whole interview because, I want Joe to have the chance to speak for himself too.
Definitely stick around for that.
So enough about JSON for now, because again, the interview's coming up. Stick around for after the ad break to hear the full interview with Joe and all that went into that. What else do we have to talk about on this part of the show, Adelina?
Yeah, so I think one of the most exciting things we have to tell you today is that the Go team have written a new post on how to organize a Go module. And this is mind-blowing to me because it's been the topic of discussion in many Go teams that I've been part of, and we've never been able to settle in a way that everyone was happy. And now the Go team are making recommendations on how to organize modules and how to organize server projects. One of the things that I was really, really surprised by is that they recommend to use the internal package to put things in there that you don't mean to export. And I was really surprised because I've never used that in production, and in any team that I've written over here in the UK, I've never seen that used. And now that I was reading it, it obviously made a lot of sense, but we've never actually done that. So I don't know, what's your experience, Jonathan? Have you used this a lot?
So I have used internal, yes. I'm a big fan. There are times when I don't want to expose something to the world, but I need to expose it maybe for testing, or maybe, by the way, if you're trying to do testing, there's a great book on testing in Go that you should check out. It's called TDD, Test-Driven Development in Go. We had the author on a while back. Adelina's the author for anybody who doesn't get the joke.
Thanks a lot.
So I've used internal quite a bit. I'm also excited about this post because I think it will help to settle an ongoing debate that's been going on for years. There has been a popular, controversial GitHub repo out there called Standard Go Project Layout, which is not official. It's not endorsed, but because of the name, people think it is. Russ Cox has asked the author to downplay that, and there is a small disclaimer that it's not official, but it's still, a lot of people think that it effectively is. This will hopefully help to correct that and provide an actual official-ish guidelines so that we can hopefully put this debate to bed a little bit and get back to writing Go code instead of arguing about which directories to put things in.
Yeah, but so important, isn't it? Because the structure will then feed into how we think about the models that we write. So I was fortunate enough, I just want to say one last thing about this topic. I was fortunate enough last year to take Bill Kennedy's workshop, Ultimate Go Service. And he talks a lot about the structure of his projects and how important it is to have a good idea of what you're trying to do and then simplify as you go forward. I don't remember, Bill, please, if you're listening to this, don't kill me, but I don't remember the usage of this internal package there either. So it'll be interesting to see if this changes the narrative of how we talk about projects in the community.
All right. Well, I think that wraps us up for the news for this week. It's been a pleasure talking to you again, Adelina. I hope to see you around before too long.
Yeah, definitely.
Stick around for our ad break and for the great interview with Joe Tsai.
Thank you very much for having me. Enjoy the show, everyone.
Congratulations on making it to our exciting ad break. This episode is sponsored by our friends over at Clothe. Clothe is a developer-friendly serverless platform to deploy apps globally. No ops, servers, or infrastructure management. You can run web apps, APIs, event-driven serverless functions, background workers, and even cron jobs. Who doesn't love cron jobs? You love cron jobs, right, Adelina?
I love a cron job.
Yeah, they're the best.
I also love serverless. So I think anything that makes
serverless is cool.
Easier management of serverless functions is a plus in my book.
Yes. Now, I personally have not used Clothe yet. I've seen them demoed, and I have a project in mind that I may be working on soon where I intend to use Clothe. But Shai, our co-host, who's not here today, has been using them, and he's very pleased with what they provide. But I want to just give a big shout out to Clothe for being our partner on this program, providing great service to Shai and to some of our listeners we know who are using it. If you're looking for somewhere to run your workload, whether it's serverless or cron jobs or web apps or kind of just anything, check out Clothe. They've been adding features almost every week. They've been sending us updates with new features they've added, new capabilities for monitoring, working with Docker images, and so on. They're really on top of the game. They're adding new features all the time. So if they don't have something you need, reach out anyway. Maybe they're adding it. Maybe it'll be there next week. So check out clothe.com. Link in the description. Let them know you heard about them from the show. Speaking of letting people know about the show, let your friends know about the show. We are excited. I was really excited when Adelina told me that her interview brought up the show. I like that. We've made it now. Now we're there. I can retire from the show in blissful happiness from now on. So check out clothe.com.
I think I was really impressed by clothe.com because they showed how easy it is to deploy serverless functions and as well as deploy them from GitHub. And I'm really grateful for you for telling us about clothe.com. And it was the only time I'd only heard about it from the Cup of Gold podcast. Speaking of the podcast, you can find it on cupofgold.dev or on the Gopher Slack. And if you're not already in the Gopher Slack, you can join it on gophers.slack.com. And then we have a Slack channel that's called Cup of Go, and you can join that and, get involved. And there's lots of cool discussions. You can propose new topics. You can propose guests, or you can nominate yourself as a guest to come on the show. And also, please remember to share it on all the places where you listen to your podcast and rate and review, please.
We love those reviews. Even if they're negative, we like to know what we're doing wrong. I haven't seen a negative review yet. I guess those people just don't, they just stop listening. I don't know.
Yeah, just stop.
Give us a negative review. We want our first one. Anyway, I think that wraps it up. Stick around for the interview with Joe Tsai about JSON encoding. Till next week.
Bye, everyone.
Today, Shai is sick, so I'm recording this interview by myself with special guest Joe Tsai. Thank you for coming on, Joe.
My pleasure.
Maybe before we jump in, I know a little bit about you because I've been following the Go issue tracker for quite a while, but I'm assuming our listeners don't all know who you are. Would you give us a brief introduction, who you are, and what your relationship is to Go?
Sure. My name is Joe. I've been working in Go for almost 10 years now. I actually started using it close to the 1.0 release. I used to be working at SpaceX at the time, and their database telemetry system was written in Go. It was originally written in Python, and some engineer comes and is like, hey, you should really rewrite this stuff in Go. And at some point, Python became too unmaintainable, and we, in a rage quit scenario on a Saturday, rewrote a good chunk of the core part of it in Go. I was like, wow, this is fairly performant and very maintainable. It's like the best of both worlds. So that's all the way from Go 1.0 days. At some point, I find myself at Google and eventually find my way onto the Go library team. But I was mostly responsible for Go inside Google. So I was responsible for like all the release regression testing, making sure Go applies cleanly inside Google. I'm responsible for a whole bunch of different internal Go libraries inside Google, some of which are not well written. You have to keep in mind, Go's invented at Google. They didn't even know what good Go code looked like. And there's a lot of weird clifty stuff inside Google. So the stuff you get outside of Google is actually the more cleaner, nicer looking stuff. All right. I maintained that for a while, did a bunch of things with protocol buffers, and slowly took ownership of a bunch of like standard library packages. And then maybe around 2 years ago, I left Google and then joined Tailscale. And to be honest, I did not understand Tailscale as a product before I joined the company.
Okay.
If you ever go on the Tailscale website, they're always advertising the fact they're like a VPN on top of WireGuard. I'm like, I don't care what WireGuard is. I'm not a crypto nerd. I don't know what WireGuard is. But then I went on vacation to Hawaii and I was like, at some point I need to VNC into my desktop at home. And I was like, usually to do this, I would have to SSH reverse tunnel, set up a tunnel, and then I would VNC into the tunnel to be able to access my desktop at home. And then I was like, wait a minute, with this whole Tailscale product, could I just put the IP address, the Tailscale IP, and it just works? And I tried that. And then I could just directly VNC into my desktop at home. And I was like, I get it. I understand what this product does. I don't have to wrangle with port forwarding. I don't have to wrangle with SSH tunnels. If I have to share a service or something, it just makes things easy.
Awesome.
But yeah, been at Tailscale since, and they allow me to work on Go standard library stuff every now and then.
Okay. So what have you been doing lately on the Go standard library?
I've been working on a lot of JSON stuff. We are talking about it a lot more openly now. This is a multi-year effort. People in the community might be familiar with Daniel Marty, Roger Pepe, Johan Brandhorst, and Chris Hines. So this all started because Daniel Marty, like 3 or 4 years ago, tweeted and how he was very unhappy with JSON, how there should be a V2. And then he and I started talking, and I don't remember how everyone else got involved.
So for those who didn't follow the tweet 4 years ago, what's the TLDR? Why did Daniel think there should be a V2? And how did that build up steam? Why did it gain support?
Basically, his tweet pointed to a Google Doc, and that doc had a whole bunch of different problems with V1. At GopherCon, I recently spoke on JSON V2, and my talk was kind of crafted into several sections, like what's wrong with V1? What would be in V2 that fixes the problems in V1? And then how would V1 and V2 interoperate? His talk was just mostly highlighting the problems of V1. And there's certainly a lot of problems in behavior. There's bugs that we've tried fixing but had to roll back. JSON is the 5th most imported Go package. So I think the top 5 is something like font, strings, IO, context, and then encoding JSON is number 5. And as you can tell, of the top 5, encoding JSON is definitely a lot more complex than the other 4.
Yeah.
So making tiny changes, unfortunately, breaks people. If you're familiar with Hiram's law, people depend on bugs. And sometimes you have to be like, look, enough people depend on this bug, so we just have to preserve it, even though it's obviously wrong.
Cool. So you've been working on, not exclusively you, but I think largely you have been working on this Go JSON experiment repo. Do you want to tell us a little bit about what the state is of that?
Yeah. So the current state is it's pretty production ready in terms of the correctness. It is already being used in certain parts of Kubernetes and certain parts of Tailscale's infrastructure. It is not production ready in the sense that we will make breaking changes. And even a few weeks ago, we made a pretty massive breaking change to the API. And so we do welcome people to experiment with it internally inside their company, but to also be very careful about whenever they upgrade the module. Not every breaking change will result in a Go build change. So we might change the behavior or something, and it's not obvious that there was a build, it won't have a compilation failure. Although as I say that now, maybe we should add something where you can like depend on some hit variable, and then if we break it, it'll like complain loudly. We should probably add that.
Yeah. Sure. So I've been following this repo kind of half-heartedly for a while, and I've seen spurts of activity, but I haven't tried using it yet. I've certainly been interested in improving or having an improved version of encoding JSON. My particular interest is in true streaming support, because I maintain a REST API library that may decode gigabyte-sized JSON strings, and I don't want to put those into memory when I do that. So what are some of maybe the highlights that you're hoping this experiment, maybe the experiment already does, or that you're hoping V2 would give us over the status quo of encoding JSON?
Yeah. The JSON experiment, I'm just going to call it V2 from now on. V2, we're going to aim for default streaming. So if you're reading from an IO reader and writer, it does not buffer the entirety of the JSON text. We'll try to do things to be more compliant with the specifications. So for example, we'll reject invalid UTF-8 by default and also reject duplicate names. That's actually one that's kind of surprising to people, that duplicate names can actually be a security vulnerability. because it's undefined in the RFC. And so you could have two microservices using different JSON implementations, and they'll disagree about what the meaning of the JSON message is. So you could imagine like one microservice is authenticating a message, and then another one's just interpreting it, right? And so I think CouchDB had a pretty bad privilege escalation attack because of JSON implementation. It wasn't using Go, but at the same time, the problem is still there. In their situation, I think it was like a combination of Java and Erlang or something like that.
Yeah.
So correctness-related problems. We have also performance-related things we want to solve. I mentioned streaming. The marshal JSON and unmarshal JSON methods, unfortunately, are quadratic if they recursively call JSON marshal and unmarshal. And Kubernetes was parsing open API specs, and people were complaining that if you pass in a 1 megabyte or larger spec, it would take like minutes to parse. It's because it's going down this quadratic call stack with constantly reparsing the same JSON text.
Yeah.
So we've got, correctness, performance, and then there's just a lot of missing feature. You go on the issue tracker and you search encoding JSON, there's just like almost 100 different issues. A lot of them, when you step back, there's a lot of similarities between them. And so we can probably solve not a direct issue per se, but be like, hey, if we provide this issue, it will solve this, 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 and half of this. And then we want to provide like orthogonal features that interact well and don't have all these weird pathological edge cases.
Is there anything like a timeline at this point for when V2 might become close to ready? When would we see it and go?
Earliest, it'd be 2 releases. So in about a week or 2, we'll start the GitHub discussion. That might go on for maybe, who knows, maybe a few months. And then at some point, it'll be a formal proposal. I suspect some of the smaller parts of V2 will make a separate proposal to add them directly to V1 first. Also to make it easier to do the migration to V2. But the V2 package itself will probably be a separate proposal. And then the most challenging part of the whole V2 is trying to implement V1 in terms of V2. And we want to preserve bug for bug compatibility in V1. Most people do not realize that is actually by far the hardest part of this effort. If V1 didn't exist, I think our life would be a lot easier, that we can roll out the cleaner, nicer stuff today. But we don't want to end up in a situation similar to, like, say, the Python 2 to 3 migration, where it was basically a hard stop. You're either fully on Python 2 or you're fully on Python 3, and you can never bridge the gap in between. For this whole V1 to V2 JSON thing, we want it to be like you're in V1, you're on V2, or you can set a set of options that make it mostly V1 with a little bit of V2, or mostly V2 with a little bit of V1, or anything in between according to your needs.
Interesting.
And one was hard to design and get right, but also we need to implement options that back every single one of the behavior chains.
Yeah.
And some of those behavior changes I cannot explain to you as a person, which also makes it hard for me to explain to a computer in terms of code what it's supposed to do. And not only that, there are parts of the JSON codebase in V1 that depend on bugs and Go reflection.
Oh.
And there are times when Matt Dembski and others try to fix the bug in Reflect, and either they have to roll back the change in Reflect, or I had to add like 100 lines of code in JSON to replicate that bug.
Wow.
It's gnarly.
Oh, I'm glad you're doing this. I'm glad someone's doing it. I'm glad that someone isn't me.
Compatibility is Go's biggest selling point. And so my goal is that people should be able to go use V1 as it's being implemented in terms of V2, and nothing breaks.
Yeah.
If nothing breaks, I'll be super happy. But there's going to be some really esoteric cases that will be a little bit challenging to try to replicate exact bug for bug compatibility.
I hope I can guess the answer to this question based on what you just said. But will V2 use the familiar JSON marshal and unmarshal interfaces, or does it have to do something new to take advantage of all these new capabilities?
Yes and no.
Okay.
JSON marshal and unmarshal functions, the signature are mostly the same, but they do take in variadic options. And that's one of the ways we're going to be able to greatly extend its functionality. For each of the marshal and unmarshal functions, we do provide 3 flavors. So the one that everyone's familiar with is that it takes returns or takes in a slice of byte. But it's convenient. Downside is it always has to allocate and buffer in memory this slice of byte. We also have one where it's called marshal write and unmarshal read, and that will take in an IO writer and reader. And then a third flavor is it's called marshal encode and unmarshal decode, and it takes in a JSON text encoder or decoder.
Okay.
So that's going to be a concrete type that allows you to parse, read and write JSON at the syntactic layer on individual tokens and values.
Okay.
And that'll be a separate package in encoding JSON/JSON text. So it'll just be a very fast tokenizer implementation.
And so that's part of what allows you to not have to reparse the JSON at every level, right?
Yep.
Yeah, nice.
And then in terms of the interface methods, we'll have to provide a Marshall JSON v2 method. Mm-hmm. And then instead of taking in, so Marshall JSON today returns a slice of byte. Marshall JSON v2 will take in a JSON text encoder and also a set of options.
Okay.
And so that allows you to construct JSON progressively as opposed to have to like buffer in memory. And it also avoids the O of n squared problem with recursive calls.
But it will still support the old interface for old types.
Correct.
Yeah. Awesome. Cool. So earliest we can expect this sounds like Go 1.23, absolute earliest, more likely later.
Yeah. I mean, being the fifth most popular package, there's going to be a lot of discussion that's going to happen. Yeah. And there's even certain like defaults that we don't know what's the right behavior.
Yeah.
So for example, we know from the issue tracker, people are not happy with the fact that a nil slice and map currently encodes as a JSON null, as opposed to an empty JSON object or array. So we know for certain through the data that people need the ability to configure and alter that behavior. What we don't know is what should the default be, right? All the issue tracker tells us is the pain points. It doesn't tell us what people would want as defaults. And so that's one of the cases where we want people's opinions, whether or not nulls or empty JSON objects and arrays is the default. Another one is when encoding, should we sort Go maps by default or not?
Oh, yeah.
So if you sort it, that's an obvious performance hit. But for a lot of systems that are basically REST APIs, they do not care.
And determinism is worth a lot for many applications.
Right. And so which one should be the default? We're definitely going to provide you the option to select which one you want, but what's the default?
Right.
We don't know. The data doesn't tell us anything.
Fascinating. So you said that the discussion is going to be coming out soon. In the meantime, your GopherCon talk, I don't know if it's been recorded or even if it has, if it's available yet. Hopefully, if it is, you can share the link with me and we can put that in the show notes when it's around. But what would you like for the audience to do? How can they help? Should they go play with the experimental JSON marshaller? Should they wait till the discussion's around and go be active? How can our audience best participate?
I think it'd be great for people today to start looking at the prototype. It's going to be at github.com/go-json-experiment/JSON. Go ahead and play around with the API, get a feel for it, try to marshal certain things and get a sense of like, does this do what I expect? Like in general, we want it to be something that's intuitive. If it does something that's counterintuitive, that's good stuff to talk about, right? A good library is one where you pick it up and you didn't even read the documentation and you just play around with it and you're like, oh yeah, that does what I expected it to do. That's good design. And we don't know if we came up with a good design. And so if something doesn't go according to expectation, bring that up, raise that on the issue tracker. We'd love to see if it like fixes performance problems that people have. We have not yet finished the whole V1 compatibility layer where you can make it identically behaving to V1. Some of the options are there. I only implemented the ones that we cared about at Tailscale.
Okay.
But I'll be gradually implementing more and more as time goes on.
Really cool. I am very excited about this. What will the new package be called, by the way? Or is that undecided yet?
Yeah, so we're splitting JSON functionality into two layers. There's a part that's just dealing with JSON purely in terms of the grammar and the syntax. And that will be inside probably encoding/JSON/JSON text. There's no need to put a V2 in there because it'll be the first release of such a thing. And then there's a thing that sits on top of that deals with JSON data as Go data and vice versa. And so that's the semantic layer, right? Semantics is assigning meaning to something. So we're assigning meaning to JSON data as Go data. And so encoding JSON already exists. So this would be encoding/JSON/V2, most likely. And then V2 will depend on JSON text. JSON text is deliberately designed to have a very light dependency tree. So it won't depend on reflect. You could potentially use in TinyGo, for example. And it's designed to just be really fast and you just shuffle JSON. But then there's the layer above it that depends on reflect. It's bloated. Sorry. If you have functionality, you're going to have bloat. You can't avoid that. But hopefully all the functionality it brings is useful as opposed to useless bloat. that you like never execute.
Nice. Well, I'm super excited about seeing this, and I look forward to seeing the discussion and participating and eventually using the new version of the JSON encoding. So I'm imagining you've also made a bunch of improvements with regard to performance. You've talked a little bit about that. I mean, certainly avoiding having to buffer the entire message before you decode it or encode it has performance implications, but I'm sure there's a lot more to it than that. What kinds of performance changes have been made or are being made with this new implementation?
Yeah. Performance is, I would say, right now, the goal of the package is actually to get correctness and behavior right. That's our primary goal. And then performance is secondary. Unfortunately, some people are not happy to hear that because they want like JSON to be like a rocket ship and be blazing fast. But we do also care a lot about it. Being part of the standard library and being something that processes a lot of untrusted data, Daniel and I, as we were discussing this, made a commitment early on that would never use unsafe. In fact, very few packages in the standard library use unsafe. It would be like the runtime, reflect, and OS, and maybe like crypto stuff. But beyond that, nothing else really uses unsafe. And that kind of led to some challenges. It's like, how can we make JSON fast? Because one bottleneck is going to be Go reflection. And anytime someone hears Go reflection, they're like, Go reflection equals slow. If you want to go fast, do unsafe. And there is like a kernel of truth to that. At the same time, we can't just like throw under the bus the benefits that reflection buys you, right? Reflection is a abstraction layer of how to do type safe operations with regards to Go values. And so like if you do something unsafe, at worst, you get a panic. In the case of unsafe, you get corrupted memory and remote code execution potentially. And so one question was, how can we make reflect faster? And if people follow the law of the reflect package and proposals around it, we made a lot of changes to reflect to make it a lot faster. We altered parts of the implementation to make things inlineable and make things no longer escape. So allocations of using reflect has dramatically gone down in the past few releases. We made a lot of the common accessor methods on reflect.value to be inlineable. And so now those are directly called as, and now dead code analysis can do a lot of fantastic things. There is another different JSON implementation that's like technologically fantastically interesting. So ByteDance has a JSON implementation called Sonic, and it uses a just-in-time compiler to compile like x86 code on the fly that exactly unmarshals like JSON code directly into the Go memory of arbitrary Go values. It's blazing fast. At the same time, it's like, I don't know if I would trust a just-in-time compiler for untrusted JSON code text.
And it's probably not cross-platform either.
No. Yeah. So last I checked, there was a lot of x86 code in there. I didn't really see support for like RISC-V or ARM.
Yeah, right.
And if you just link in Marshall and unmarshal, it was like 25 megabytes.
Wow.
But if you really want to go fast, there are options out there.
There are times when that's appropriate. Yes.
Yeah. But like the Go developer survey showed, more people cared about reliability and correctness than they cared about performance. And so I think that's probably the right balance to strike targeting safety and depend on reflect, but try to get reflect as fast as you can. And there's still a few areas that we can still optimize reflect, especially around Go maps. I have a few proposals out there for more allocation-free APIs. In terms of how we can get the JSON decoding part of it faster, Rob Pike had a talk that he gave about a decade ago called I think it was lexical graphical scanning or something like that. And in that talk, he presents an approach to scanning and parsing data that I would say is kind of elegant. It's basically for every byte of input, it's going through a dynamic function call. And you parse that input and whatever are the you maintain your state based on which function you're going to call next. Mm-hmm. And the elegance of it is you just process that function. You look at the byte your input you're processing, and then you determine your next state you're going to go to. Mm-hmm. And it's just your state machine is determined. The downside of this is you're going through a dynamic function call for every single byte of JSON input. Mm-hmm. And the V1 JSON package is implemented in terms of that Rob Pike approach. The benefits, it's simple. The code complexity is not all that complicated. It's really relatively easy to reason about why it's correct. Downside, it's slow. Mm-hmm. In V2, we took a more iterative approach to scanning, as if you're processing from an entire slice of bytes. The downside of that approach is how do you handle segmented buffers, right? You're reading in from an IO reader. You only have a segment of your JSON text and you don't have and so you need the ability to execute and parse, but be able to pause your execution and then resume it arbitrarily from certain points. And so we took a more natural approach where you're processing from a slice of bytes, but then there's a lot of complexity where you can jump into the execution arbitrarily, knowing that it's like, oh, I've already processed this first part of a JSON string, and now I can resume from this part. Or I've already processed this part of a JSON number. I can resume from this part, and I know it's right after the exponential of the JSON number. And so there's some more complexity with state tracking that's held out of band, but this approach is much faster. Mm-hmm. So pros and cons.
Yeah. You mentioned earlier too, I think before we were recording, that this is, did you say the fourth JSON implementation you've written?
Might have been third, fourth, or fifth.
Yeah. Were these all in Go? Tell me a little bit about your history. I'm curious how you got here.
Let's see. I think some of my earliest was writing a JSON formatter in Go, just because I wanted some ability to format JSON, and I wasn't aware of one that existed at the time. Mm-hmm. And then I became the maintainer of protobuf. And in the implementation of proto-JSON, which is the ability to marshal protocol buffer messages as JSON, the specification for that says it has to comply with, I think, RFC 7493. I might get that number wrong. But anyways, it's a stricter standard of JSON that in particular rejects invalid UTF-8, rejects duplicate names. And the standard library, unfortunately, fails on both of those regards. And so we couldn't use the standard library for it. And so I had to build a different JSON tokenizer. Mm-hmm. So if you go to like the protobuf module inside internal/encoding/JSON, there's yet another JSON implementation. And then, let's see, Daniel Marchi has a Twitter post where he rants about all the problems in V1. Mm-hmm. And he's like, hey, we should start thinking about a V2 JSON. And this is like 3 or 4 years ago. And so he and I start talking, and I'm like, hey, I've done several at this point. And so that was kind of the birth of the Go JSON experiment. And so I guess that would be the third implementation. And then I work on that for a few years. Then I joined Tailscale. Tailscale has these policy files that are implemented in terms of JSON, but extended with comments and commas. We call it QJSON for human JSON.
Okay.
And I write yet another parser and formatter for that variant and flavor of JSON. And maybe I've done a few other prototypes here and there that I've completely forgotten about over the years. Yeah, I'm very happy to be able to unify all those.
You just like eat, breathe, and sleep, dream JSON, it sounds like.
Sort of. I've been around serialization because I did a lot of protobuf too.
Yeah, okay.
But I like JSON because it's humanly readable. And there's no doubt it's the world's most common data interchange format. Protobuf, it is popular, but it is at least 2 or 3 orders of magnitude less popular than JSON.
Right. Yeah.
And there are other issues of protobuf that I may or may not get into if you want to find out.
I was going to ask, do you like JSON, or is this just a necessary evil? But you just said you like it. Maybe there's more nuance than that.
I think JSON is almost perfect when it comes to a textual-based serialization format. Okay. The major detriments of it is it doesn't have true support for integers. Technically, you can encode an integer that's like 64-bit, but like all the RFCs say, don't do it because a lot of implementations represent it as a float. That's really the JavaScript world leaking out. The other issue is if you do encode a float, you can't really encode any nans and infinity, which means you can't have like a perfectly bijective representation of floating point numbers. Is represented in like an IEEE 753 or whatever. There is I don't want to say JSON compatible. There is a JSON type system compatible binary protocol called CBOR that I'm very excited about.
Yeah, I've seen it. I've not used it.
CBOR allows you to represent all of JSON. So like the entirety of the type system in JSON is representable inside CBOR, but it's binary, which is really cool. The only thing, the representation of CBOR, I read the spec, it's really elegant. I really love the way it packs bytes on the wire. My only grievance against CBOR is they have a concept of a object, which is essentially a mapping of key value pairs, but their keys are not limited to just strings. It can be any other CBOR item. which
Oh,
opens up a whole can of worms of like, what does it mean for two keys to be identical? And I would say
yeah.
the biggest complexity in that specification is essentially answering that question. And I don't think it's like particularly well answered either. It's
YAML
still
does
kind of
something
ambiguous.
similar, doesn't it?
Yeah.
It's a pain there too. Yeah.
I personally think it's a mistake. Like the reality with data serialization is you need it to be representable easily in any language.
Mm-hmm.
And so like, how would you even implement that in Go? In Go, we can have any key type that's comparable by a Go definition of comparability.
Mm-hmm.
But like in CBOR, you can represent like a entire map or like a slice of something. And Go would just be like, we don't let you express this at the language layer.
Yeah.
And so how would you write a fully compliant CBOR implementation in Go? I guess pretty hokey.
Yeah.
And that's true of other languages too.
Sure. Well, if people are interested in following your work, obviously they can follow the GitHub repo. Are you on social media? Is there some way that people can follow you directly, or do you prefer to stay below the radar?
I'm sort of a little bit below the radar. So they can certainly follow my GitHub profile, which is dsnet.
Mm-hmm.
I do have a Twitter, which I don't even remember the handle. I think the handle is _ Joe Tsai. The fact that I don't even know my own handle tells you how rarely I use Twitter.
Right. Did you know it's not called Twitter anymore?
Yes, that's what I've heard. I did work for an Elon Musk company.
Okay.
But if people want to reach me, I think my email is listed on GitHub. So I'd love to hear feedback. I'm happy to correspond with people or chat about things.
Well, I warned you before we started recording that we always ask 2 questions, and I'm actually going to tweak it a little bit for the topic today. I'm going to ask you 4 questions, but I'll start with the 2 original questions.
This is not what we agreed upon.
I know. I'm changing the deal. Pray that I do not change it again. So somebody comes to you and says, Joe, we have to take a feature out of Go. It's gotten too big and too complicated. What would you remove?
Complex numbers, hands down.
Awesome. I love it. Yes.
I see it leaking into like Go reflection. You have like 2 built-in functions for it that like almost never get used. And I can prove to you through the data it is very rarely used in Go.
I can imagine. Yeah. All right. And then on the flip side, let's say you have the freedom to add any feature you want to Go. Let's say JSON v2 isn't one of the options to the answer to this question, but what else would you add to Go if you could?
I'm really excited about iterators, but it looks like that's coming, so that's not going to be my answer. There's a proposal for more type eliding. So the ability to elide types even inside, like, for example, function call or like a struct literal.
Oh, yeah. Mm-hmm.
And I think that would just make Go code a lot cleaner.
Yeah.
I think one of the reasons why people don't use like a struct type as options is because it's really annoying typing like the package namespace dot options struct, and then, but it'd be really cool if you can just elide that because the function knows exactly what type that is. So you just put the curly braces, and now you can have what is essentially very similar to Python, where you have the args and the KW args, right? Because you have the unnamed ones, but those are order dependent, and then you can have the named ones. And essentially it's a Go struct, but now you don't have to put the type name. You just put the curly braces and you just put these parameters. It just look really clean.
Love it. Cool. All right. So the 2 trick questions, or the 2 surprise questions that I didn't warn you about. Same questions, but I'm going to change them a little bit for the topic today. If you could add a feature to JSON, what would you add?
True integers.
Uh-huh. Good answer.
And true integers and true binary support.
Okay. So you don't have to base 64 encode your JPEGs or whatever.
Well, I guess that would go against the fact that it's textual based, but at least some ability to identify a JSON string and know this, the intent of this is to encode binary data.
Yeah. Okay.
Because right now we look at it and it's like, it is valid base 64, but was it intended to be binary?
Right. And I don't know if there's a good answer to this one, but hopefully you'll have one. What would you remove from JSON if you could?
Almost nothing.
Yeah.
So what it does have is pretty good and elegant. It's just, it's mostly the missing of just a little bit more.
Would you add comment support to JSON? Because that's a popular request everywhere. Or do you like it without that?
I wouldn't. I know we use it at Tailscale. I think it's totally valid to extend JSON and just call it something else.
Mm-hmm.
Because the moment you add comments and commas, you're now forcing every single situation that really doesn't care about it, like RPCs, to have to support this stuff. And it's really only useful in like configuration files. And so like, I think it's totally valid to just say, that's not really JSON. It's JSON. Nitro Tau calls it JWCC, JSON with comments and commas. And so just call it something else. And
Cool.
we can all agree that that's that, and we move on with our life.
Nice answer.
I mean, the other part of it is like, in terms of the JSON tokenizer implementation, it's really nice that I don't have to add API to express, oh, you just saw a comment. Or even in terms of the commas, this is not something people realize, but if you ever use the tokenizer implementation, either in V1 or V2, you'll notice that there's no API for commas. And the reason for that is there's only one possible representation for when commas exist.
Mm-hmm.
The moment you have a possibility of a trailing comma in the last element, now the question is like, do we provide API that allows you to explicitly emit that? And it's kind of nice that the APIs for all JSON libraries out there don't have to deal with this because it's implicit.
Yeah.
And that's a cost that people don't think about. I love comments and commas, but let's just call it something else.
Yeah, fair enough. Cool. Well, Joe, thanks for coming on. It's been a longer chat than we usually go for, but I think it's been a very interesting one, and I hope that our audience appreciates it. So thanks for coming on, and talk to you when V2, I guess, comes out.
It was a pleasure. Have a great day.
Awesome. Talk to you later.